Welcome everyone to our Twitter space, special Twitter space today regarding blockchain security across the whole development cycle. When you develop a DApp through the whole cycle, from the coding through the auditing, deployment, and shipping it to mainnet to production. And today we have some super special guests here on the Twitter space. First, we have Emiliano, which is an independent Web3, very known Web3 security researcher. We have also Jota, a Web3 security researcher from OpenZeppelin, and the one and only CEO and co-founder of OpenZeppelin, Damian. So welcome everyone, glad to have you here. As I said before, we're gonna discuss about the development life cycle and the security that comes in every step of this life cycle. And it's going to be a very interesting conversation. But guys, all the listeners, if you have any questions, if you want to say something, just, I don't know, you have a questions or you want to tell something, you can always ask to be speakers or write your questions in the tweet itself, write as a comment, and we will have dedicated time at the end for Q&A. So we will try to answer your questions. And yeah, now before we deep dive into our conversation today, let's have a short intro of every one of our guests. So I will start with myself. My name is Johnny Time. I am the co-founder and CEO of Ginger Security and a Web3 security educator in the space. On YouTube, also the creator of the Smart Contract Hacking course. And I'm glad to be here and host this space. And let's hear a bit about Emiliano.
Thanks for having me here. I'm Emiliano. I've been working in DeFi and Web3 since 2020 as a builder, but more well known as the war room guy, helping on the security side a few protocols.
I'm Juan Carpanilli. I'm a security researcher at OpenZeppelin. Joined the company around 5 years ago, first as a software engineer, working in the OpenZeppelin contracts team, and now working in the security services team.
Hi, I'm Demi, founder and CEO at OpenZeppelin. So I've been in crypto for over 10 years now. Founded the company about 8 years ago. Happy to continue being part of the industry in its ups and downs and its changes, and look forward to that.
Awesome. So thank you everyone for the intro. And to kickstart our discussion, first I want to ask you, Demi. So DApp development lifecycle, either if it's a DeFi app or NFT app, it's a long process. And we already know that security needs to be through the whole process. And usually we put most of the focus in the auditing section, but it's not enough actually, because we see that even audited protocols are getting hacked. So before we talk about the security aspect of it, can you please describe briefly the whole development lifecycle of a DApp, like what stages it includes and the importance of each stage?
Sure. So in our experience at OpenZeppelin, working with thousands of blockchain developers, both at small startups and communities, as well as big enterprises and even DAOs, we had a very good understanding of what their processes look like, both pre and post deployment. What are all the stages involved in planning and writing code, putting that code on chain, and then once the code is on chain, how do you operate that? How do you monitor that? And of course, we learned that security, as you said, is not just an audit, but it's a continuous effort. Security done right is a multi-layered approach involving a combination of technology, processes, and people, which basically, what we're trying to do is drawing the inspiration from all the years of best practices in Web2 security, but adapting them to Web3 with the nuances of these technologies. So in terms of the stages, it starts with the plan stage, and again, this is not unique to Web3. This is there's a whole DevSecOps practice in Web2 and beyond that talks about all the stages. It starts with the planning stage, thinking about what you're going to be, how you're going to do it, what the integrations will be. Then projects move to the code phase when they start writing the code, then move into the build and testing stages, building the code, testing it in their different environments or scenarios. After that's conducted, then you go into the release phase, and that's usually when projects get an audit, once they finalize all the code and all the testing. And once the audit is done, the big moment comes for pushing the red button and deploying code to the chain. So that's when we get into the deployment stage. And after the deployment, you get into overall monitoring operations. So these are two different stages. Monitoring involves watching what's happening with your system, trying to understand behaviors and also anomalies or potential threats that could be happening, so that based on those understanding, you can operate and you can react and make changes, which basically goes back again to the first stage. Once you understand what you want to do, then you plan it, then you start writing code to implement it. So this cycle ends up being like an infinite loop that makes product better and better.
That makes sense. It's not just development of the code and then auditing and deployment, but it's like an ongoing process. And like we know from Web 2 traditional security, and in Web 3 security, it's pretty new. The most of the focus goes through the audit phase, but when it comes to IR, incident response, and monitoring, I think we're a bit like lagging behind Web 2 security and existing companies that are doing that for years in the space. And this one is for Emiliano. So, considering the whole development lifecycle, which one do you think is like the most like critical and where we have the most pain in terms of security? Is it like the planning phase, the coding, the audit, the deployment, the upgrade phase? Which one is like the most crucial and critical, and why?
Yeah, I would say that the answer every stage is a problem, is not valid, but I would say that probably the most important part is the first part, because down the line becomes more harder to make reversible decision. So when you arrive to the deployment, then it could be too late, to change maybe some design decision. So I do think that in general, the other stuff is finding a good trade-off to make the code efficient and ship quickly and the security. So we already know that premature optimization are evil also from the Web 2 world, or that you would like to be able to stop in each part of your protocol, but you cannot do otherwise, so you would be custodial. So being able to have a good degree of control and being able to help in case of urgency is something that you need to do. But again, I think that the most critical part is the design phase, the planning phase, where we are thinking about a cycle, a flywheel, But in the end, you always have to have in mind the pillars of security. So you have to know that your code should be able to monitor efficiently, should be able to be maintained efficiently. You should be able to build dashboards maybe on top of your code. So in every part of the process, you have always to have in mind which are all these stages. So that's why I think that being able to have an eagle-eye view of which part, I think that this is the most difficult part, especially for, let's say, less experienced people joining, rushing, and building a protocol, having, this broad overview of all the pieces that you should do. Because maybe you arrive late at the deployment, you say, oh, we need to be able to stop, or we need to be able to monitor that. And in the design phase, you didn't thought about that. So having in mind all those pieces in the first part is the critical and other stuff. Also time-wise speaking.
Which is a bit challenging actually to predict all those things when you are in the design and planning phase. Like how can you predict in the future what things you need to monitor, or in case of an emergency, what kind of access rights, administrators, centralized access rights you need in order to save the money? Like,
That's a fair point. That's why you have to have security is very transversal, So it's you don't have to do security at one stage, just on the audit, just on the contest, just in the design. You have to have a security mind. It should be part of the culture. It's like more. I think Damian shared did a good reference to the DevSecOps model. It's like if you build it, you have to operate it, you have to monitor, you have to secure it. So the idea is the same mindset. So in your principles, you have to think, okay, iterate quickly, engage security folks at the very beginning during the design, so you are able to design, code, deploy, monitor what you deploy. So you see from the beginning all the things that you may need, and only at the end it becomes more a logistical thing. You deploy or mainnet, but do all the life cycle before. When you arrive at a good maturity stage, deploy.
Yeah, I completely agree.
I completely agree. It
Deploy
was mentioned.
on mainnet.
I completely agree, and it was mentioned by many security researchers that just in the audit phase, it's not enough. You need like at least one security researcher or a company that like take you through the whole development lifecycle.
I think you raised a really good point about striking the balance between moving fast and staying secure, because in the end, there's no such thing as perfect security, and it's a mindset and an effort. And Johnny, also you said that, how can you predict in advance all the things that you will need, and how do you integrate security or things that maybe you don't even know? And our approach, or how we've been thinking about this at OpenZeppelin, is that in the end, you need to encode best practices into processes and then build technology so that those processes and best practices can be easily executed by the right people. So again, the combination of technology, processes, and people. And that's kind of the approach that we've been taking with Defender. And today, we announced Defender 2.0 version, which takes security to a whole new level with a kind of like a development lifecycle integrated experience. So I think lowering the barriers to entry for any developer to implement security across all the stages is key if we want this industry to scale to the trillions.
Definitely. So first of all, congrats on the announcement of Defender 2.0. I had the pleasure and the honor to take a look at it before it was out on the beta version, and I've got to say that it's one of the craziest products I've ever seen in Web3 security. I mean, it's really impressive, the whole features that it includes and the way it's designed through the whole life cycle of the product. And I would be interested to hear what's your take on it. What are the most the most difficult points in the development lifecycle? Is it like which phase and like what pain points there are?
I will here echo what Emiliano said. It's very, very important for developers to have a defensive mindset right from the beginning. When they plan, they not only have to plan protocols to do certain things they want them to do, but also they have to get the mindset right to understand that these protocols can be hacked at any point when they are deployed. And yes, the first step would be to have a standing of defense when they code. And this brings a lot of other things, such as you might need tooling around your project to raise vulnerabilities that you may not know that you have before an audit, but they're great for you to already have listed to fix them before you go to security audit. Something that I face all the time as an auditor is that I have to, so as security researchers at OpenZeppelin, we are very nitpicking and we try to raise as many issues as we can. These are from critical security issues where $200 million might be at stake, or just a typo in one comment that might not be accurate. And if we could at least have something that allows us to get like 50 or 60% of these issues that might be the nitpicking ones, but also might be like medium or high severity issues ready for developers to tackle before security audit, that makes or would make the process for auditors 10 times better.
That's a very good point. So, okay, so the developer needs to be aware of the security through the whole process. This is clear. Now, let's say the monitoring and the incident response phase, right? Because, okay, the protocol was audited, it was deployed on mainnet, there is TVL growing up slowly. Now, when it comes to the monitoring of, I don't know, the events, the transactions to the contracts of the system and the incident response, what do we see currently in the space? This is a question for Damian. Like, it feels like we're a bit behind, like very much behind in the space. So there is now this like new Telegram group of the emergency situations. We have some teams that are doing incident response, but there are so many DeFi protocols that just cannot afford it. You know, they cannot afford like a team of people that will do like bytecode analysis or transaction analysis. So I think this is like a very big pain point currently in the ecosystem, in DeFi especially. And I would like to hear Damian's thought around that and how maybe Defender is actually helping to other DeFi protocols, maybe with lower budget or lower TVL, to afford also monitoring and incident response.
Sure. I would say the crypto community is still a little bit nascent in terms of monitoring and incident response practices. That being said, there's been a lot of growth in terms of monitoring tools in the past year or so, as well as, you have the SEAL 911 group, which is pretty cool. And I like that the crypto community kind of finds its ways to solve its own problems. So that's fantastic. That being said, there's the main challenge is how do you know and identify which risks you need to monitor for, and once you, let's say, get alerted on a particular anomaly or situation happening, what do you do about it?
Exactly.
So let me give an example. Something that we have in Defender 2.0, we have a monitoring module that comes with pre-built templates. So, it automatically reads your contracts, and based on your contracts, it suggests you with particular monitoring templates that will apply to your protocol. And those risks are categorized based on whether technical risks, financial risks, and others, as well as there's an integration with the Forda network protocol, which is pretty cool. Forda has done great progress in machine learning detection of threats and scams, looking at transactions in the blockchain, trying to find patterns. So we have an integration there. And not only that, but there's an incident response module in Defender 2.0 where anyone can predefine a scenario. Basically, think let's say if one of the pools in my protocol gets drained, what do I do? And you can predefine all the actions that you need to take in case of that happening, where those actions are sending transactions to move funds from one place to another, contacting SEAL 911, or contacting an exchange. And the beautiful thing about Defender 2.0 is given that it has an integrated experience across different stages of the life cycle, you can do something which I think is pretty cool. For example, you can trigger an incident response scenario based on the alert of a monitor. So in that way, we're moving forward towards more guardrails and automated actions preventing harm from happening. And of course, for that to actually happen on a massive scale, you need to have really good detection of threats, so like really low false positives. But I'm confident that the work that Forda is doing and others are doing in the space will get us there shortly.
Exactly. So it's very important, like, to filter those false positives, because if for the people among us that come from Web2 traditional space, who knows the difference between IDS to IPS, intrusion detection system, intrusion prevention system, if you just install an IPS prevention and you just activate it to prevention mode, you're going to have so many false positives, and your IPS will start doing things that you don't want to do. So it's really important to filter those false positives. I mean, so Juan, I assume that you have some experience with the with the Defender 2.0, like the most amount of experience, I assume. So how do you guys like filter those false positives, or like know when it's like the time to trigger an incident response action or not? Like, how does it do that? It's interesting.
I think the question should be more focused on like, do we have the tools to do this? Like, is it possible to perform these things? OpenZeppelin, in contrast, has had the possible contract out there for a long time, but people would not use it correctly, or yes, maybe have a function that is possible or a contract that is possible and a particular function ready to be paused, but they wouldn't have the tools for actually pausing it before certain hack passes, or maybe if you see that something is going on, as David said, stop the process of the hack and maybe not reduce the losses to zero, but mitigate it as much as you can. So the first thing would be verifying which functions in your contracts should be possible. And once you define them, have the right tools that Defender provide for actually calling those possible functions. Then is, of course, all about doing the analysis of certain things that can happen in your protocol that requires some manual verifications and some deeper studies. But for me to give an example would be if you have a function that is a function to withdraw funds from a contract and you have another to deposit functions to a contract, those two, or at least the deposit function, is probably a good function to be deposited, because usually hackers, when they try to steal funds, they might use a flash loan, and when they use the flash loan, they need to deposit funds to a contract to move certain balances, to change certain prices, or things like that. So once you define which functions you should pause or should be possible, then it comes the process of like, okay, now that I have this, these are my 3 or 4 functions where funds get in and out of the protocol. Which are the different interactions that can happen that would drain or would reduce the amount of money held in the contract? And if this happens, okay, how to act from that? How to reduce the false positives? Going a little bit to your question, would be tied it to the time developers spend thinking about different scenarios in which this could be mitigated, in cases in which funds can be stolen.
Yeah, that makes sense. So first you need to write the contract in the way. So that's why you need the security in through the whole phase, from the planning to the coding, because you need to add those possible modifier to the critical functions. Now, Emiliano, sorry.
Just one more thing to add, and yes, and also that button that you should be able to press to pause the contract, and this allows someone to take the funds from there, and being able to write all those scenarios or test all those scenarios is like a great starting point.
Yeah, great point. Now, the thing about attacks that they happen really quickly, sometimes it takes like seconds, because the block depends on the blockchain and the block time. Emiliano, from your experience, if you from attacks that you've seen, or like incident response that you participate in or just observed, what is like the average time of attack from the point it starts until like the whole 200 millions are drained?
Good question. I would say that my expectation would have been that more attacks would have been executed atomically. So atomically with a private mempool. So with no traces before the attack. But instead, we measure with facts that instead many attacks are prepared and deployed days before. So in general, you will see someone that will fund via Tornado Cash or via any other, let's say, untraceable means, a new contract. In this contract, as a bytecode, you have died in plain sight the addresses of the protocol that should be attacked. So there is neither any runtime generation of those addresses. And basically the attacker many times executes the transaction in public mempool. So the most, let's say, trivial detection system can see in advance those things, if of course configured properly and set up. So it's very hard to me to say, okay, could be just 20 minutes, could be days, could be hours. The most common thing that I saw is that after the initial attack, it's easily, quickly, an incident response team or a war room will set up, and also immediately some other attackers start to compete. So in general, you will see more than one attacker, especially if then the thing goes public. So that's the my view on the attacks or on the war room that I watched very closely or participated with.
Especially, obviously, and especially, I highly agree with you, especially with the fact that the mempool is open and we have like MEV bots all the time. Usually, we saw it many times that the attacker is trying to execute an attack, but actually there is a bot that just did generic MEV, copied the whole smart contract, deployed himself, and ran the exploit, executed it before the actual attacker who designed this malicious contract were able to steal the funds. And it brings me to another interesting question, like, how come the defender is able to compete with those bots? I mean, it needs to react pretty quick. Now, we do have the signs before, like, wallet that is funded by Tornado Cash, or like these kind of things that happened before attack, this like in the attack kill chain, let's call it. So, but still, we need like to have speed. So I guess, as far as I know, OpenZeppelin Defender has both the on-demand incident response and also the automatic one. But how does it able to like stop the attacks and compete with MEV bots or like high attack transaction fees and stuff like that? This is for Damian or Juan or anyone wants to answer.
Yeah. So again, the incident response module on Defender allows you to set predefined scenarios and actions and basically trigger those automatically based on the alert received through a monitor. And actually, there's a Ford integration that introduces kind of a detection, or let's call it like a suspicious activity feed into Defender. And then Defender as well has Flashbots integration. So the response to an incident also can be protected from front-running attacks through that integration.
That's a super cool feature. Yeah. Which is currently only with Ethereum.
The fact that you can have all this information in one place, it's interesting because you can have a script to check transactions that are happening in the mempool, or you can have a monitoring infrastructure checking for transactions that happen in the mempool. And you can work on this data. You can see all this data and maybe, as was said before, classify different transactions into these transactions might not be good, or these ones are like legit transactions that are happening to protocols. So for example, if you have a transaction that you see that someone is funding a contract through Tornado Cash, or someone is moving funds through Tornado Cash, and that if goes to a certain contract, you can already have a database of all the addresses that in the last X days, X months, whatever, interacted with Tornado Cash. Not saying that Tornado Cash is just a way of like hacking programs, because it's not like that, not at all. But people use Tornado Cash for that sometimes. So in that case, if in your protocol, in your incident response architecture, you can actually check for this, and if you see that one of these suspicious addresses interacts somehow with your protocol, then it's all about defining how much risk are you willing to take. If you're willing to take small risk, you might not do anything, wait for the first transaction to happen, and after that first transaction happens, use an automatic function posting functionality, or just send an alert through Defender to a certain actor to be able to press the red button to post the contracts. If you don't want to take any risks, then if one of these addresses interacts with your contract, you can just shut down the contract at all, or at least all those functions that you might find good to implement posting functionality.
That's impressive. These are game-changing features that I've never heard before in like deployment of DApps and monitoring and incident response. And I'm sure it will be very useful for a lot of protocols. Now, it brings me to another interesting question, actually. So I'm coming from traditional cybersecurity, and it seems like the Defender system has a lot of power, especially if it has the ability to make these kind of auto tasks. And I know as a traditional penetration tester or security researcher that if you come to a network that has, let's say, McAfee EPO, it's like an antivirus that runs on all the endpoints of the network. The goal of the penetration tester is to take control over the McAfee orchestrator server, because if you take control of the server, then you can push agents through the all endpoints in the machine. You can put your executable and push it through all the endpoint at the machines. Which brings me to the question, like, how do you guys make sure that actually Defender is safe? Because it has a lot of permissions, a lot of powers, especially we know that protocols usually has like multi-sig wallets or MPC. So how does it actually work, the automation, the incident response automation? And how do you make sure that if someone get access to the dashboard of someone's Defender, it's not actually becomes a risk? Hope that makes sense.
I think that's a great point that you're raising, and there's multiple approaches that we take in that respect. First, different actions have different risk profiles. So you can set up in Defender different methodologies for executing an action. Let's say if it's an operational action that's super simple, then any one of your team members can do it. Then if it's a super high risk, posting a protocol, maybe there's a multi-sig involved, and you need, that's executed. Actually, that's not executed in Defender, but we have an integration with Safe app. So all the signing happens in Safe, and then Defender reads from that. Then some of the transactions happen through a relayer that is hosted within Defender, but that's mostly for, again, like low risk profile actions.
So you have like an access control system within the Defender, and every action has like different access. That's super interesting. So we talked about,
something that I found out recently is, so one of our clients that use in Defender is a big bank, and they, in their country, they have strict regulations about who in the bank can make certain decisions. And actually, if those settings of who can execute certain actions is set wrongly and something happens, how people can even be liable on a personal level. So they were super strict about Defender having these access control features. So, I would say we spent a lot of time thinking about that and trying to do it right.
That's very important. So we actually discussed about the planning phase, the auditing phase, and a bit about the monitoring and the incident response, but the deployment is not less important. In the deployment phase, actually, especially when I'm saying about deployment, I also talk about upgrades, because most smart contracts are upgradable these days, and most of them are using either the transparent or the UUPS or the diamond standard. But I want to ask you, Emiliano, like, some cases where the audit was perfect, everything was perfect, but actually when it came to deployment, when it came to the state of the contract on chain, there was a security risk that led to a compromise or could lead to a compromise. So it could be a bug bounty that was reported because the contracts were okay, the commit hash was fine, the audit was fine, there was no security issues, but because a certain state that it got into, something went wrong in the deployment or the upgrade process, then it led to either a loss or like a bug bounty that was reported.
That's a good point, and especially at the border between the, let's say, off-chain and the on-chain, some issues can happen, like the ones that you mentioned, and some challenges are present, because how do you verify that effectively what you audit is what you deploy? Do you audit the deployed code? Do you have some guardrails? There are different approaches. I think that right now, also with the advancement in the ZK space with storage proofs, it's easier to verify off-chain stuff on-chain, and this could help. But talking about an example, I remember one big lending protocol that proposed an upgrade, was audited, was checked about everything. I don't want to do names, but everyone that's seen it know about what I'm talking about. Basically, everything was perfect. Everyone did their own job. Also, the governance, okay, when they voted for it, said, okay, that's perfect. It works. The tests are okay, blah, blah, blah. When it was deployed, when it was enacted, basically hanged all the borrowings against ETH. And there was basically like $1 billion in the protocol. And since with a governance, you need to wait for 3-7 days, depending on the governance, basically no one can revert those things. And so people start to figure out, okay, how we can improve better, because how you can verify that when an upgrade happens, all the system continues to work, because isolated, that feature, that upgrade to the lending part of ETH was working. But when integrated in this current system, it wasn't. And one approach is basically that when you propose an upgrade, immediately later, you have some hook that basically check the already deployed version, the upgrade, and do some basic, let's say, in this case, could do just a basic lending, can borrow just one way of ETH. And if it reverts, automatically the upgrade reverts. So one approach to solve this kind of scenario is to, in the upgrade, just don't upgrade the software. In the same run, check that it's then working. If it's not, thanks to the atomicity of the blockchain, we can revert the upgrade. Okay, that was a clear example for me of a very big protocol with strong security practices, with very great partners that was doing a great security job, but we missed just 1 cent and everything.
Yeah, definitely. I can relate. There are many examples of these events where the audit goes perfect, everything goes perfect, but there is just one state variable that is being changed or there is a mistake. It happened in a bridge in the past where the initialized state variable was 0, so anyone could just provide those signatures, not signatures, those Merkle proofs and drain those bridge. It happened with a token list, and there was a USDT instead of USDC, and the decimal points were different, and it affected the whole protocol. So the deployment is not less important than the audit phase and the IR and the monitoring, in my opinion.
I would add also another color on this that I think that it's pretty important. And honestly, I didn't see any Web2 approach to this, probably because we already have those things. Currently, upgrades or let's say protocol parameter changes are managed or by multi-sigs, mainly by multi-sig. But we have tools from Web2 like Ansible, like Terraform that help you to basically
Compare.
version compare, and you are able also to run maybe daily checks that on your CI that basically the parameter didn't drift, and if they did, you execute the action to bring the protocol to the expected state. I do think that if we start to approach deployments like we do deployments. I mean, not deployments, parameter changes like we do in Web 2, because we do the best there. Probably we are going to mitigate or avoid
those kind of attacks.
Those kind of attacks.
For instance, yeah, from my experience, for instance, Yearn was doing a very great job with the multisig where they were coding effectively what they were going to change. So it was easily to see the simulation if there was some drift in previous parameters changes.
Yeah, so I guess that Defender 2.0 also helps with the deployment process. And I would be interested to hear either from Juan or Demian, like how the deployment module in Defender is maybe helping or will help in the future to prevent. Can you hear me? Yeah. So how Defender helps in the deployment process, or I don't know, like Emiliano said, like compare those state changes, like in the CI/CD process in the Web 2 world, and maybe it's even integrated with the IR. So if there are some deployment changes or upgrades, and it could bring maybe an alert and IR action. So yeah, if you can shed some more light on that area.
Jota, do you want to go, or should I go?
Yeah, sure, I can go. Yeah, so always the first step should be to prevent these things to happen. Let's go back to the example that we said before. Like we had a protocol, we audited it, everything is ready for deployment. We're going to deploy to mainnet, but a developer notices that they want to change something, just a variable name, or maybe just a variable order, the order of two variables, just because they wanted to, it was going to look better. They wouldn't ever think that changing a variable order would change anything between the first deployment of an implementation and the second deployment. So basically, it's through an upgrade that would basically break the storage layout. So here is where preventative tools come to the game. To check the storage layout before each deployment of different implementations of the same contract is key. Being able to check that, actually Defender 2.0 comes with some of this functionality for you to be able to check that you are not breaking the storage layout between one version and the other one. And then, of course, we are not talking that we only deploy mainnet these things, but we also do it in like multiple L2s and other blockchains, and also simplifying the process is key. Writing scripts for each blockchain, which you have to write for the constructor or the initializer function, the different parameters. Sometimes these parameters are called data. So we are talking about that you have to send an hexadecimal variable, or just like the bits, like the long string of bits. Could also be cumbersome, could also be very error prone. So being able to do this in an easy way by having the tools, the correct tools to do it is key. With Defender, you can actually perform these things because you can work in multiple blockchains, not only in mainnet, and you can actually check what's the state of a contract after deployment in multiple blockchains.
Yeah, that's great. And if I may add, based on what Jota said and what Emiliano said, really cool feature about Defender deployment module is that it allows you to test the deployment either on a testnet or in a forked chain or on a local network, mimicking real world situation as much as possible. And we always see that when you do that, there's always something that goes wrong. And then verifying that the same code deployed is the one that was audited is key. So there's a bytecode verification feature within Defender that allows you to do that automatically. And the beauty of all of this is that Defender integrates with Hardhat and soon Foundry. So by adding 5 lines of code to your configuration in Hardhat, you can get all these features really easily.
That's super cool. Just you basically gonna edit your hard or Foundry config file, and automatically it will integrate with the deployment model in Defender and do all those checks automatically, right? Yeah. All right. So it's very exciting, and actually, I just posted a video on my channel this week about the fact that last month $390 million were stolen across Web3 protocols. I mean, it's all kind of things, including scams and approval scams and seed phrase hacking. But still, this number is pretty high. And I want to ask you guys. Let's start with Emi. Like, where are we going wrong? We have audits, we have auditing contests, we build products. How can we get better, and how will the industry evolve from here? And what will be the role of Defender 2.0, of security researchers? What do we need to do better?
Yeah, in the end, security done right is a combination of technology, processes, and people. And so far in the space, we've done a lot in terms of people, doing audits or basically building custom scripts or solutions, but that's not scalable. And even though best practices exist out there, it's really hard for any developer that's not a security expert to implement those best practices into their project. No, an example is another cool module in Defender 2.0 is the code module. Basically, for every pull request, any developer can get a report under analyzing vulnerabilities in their code and using either our static tooling and also our machine learning detection. And the beauty about what we're doing there is not only this is integrated into the development process within GitHub and a GitHub app, but also we put a lot of effort into making those reports as friendly as possible for any developers to use and reducing false positive as much as possible. So again, you don't need to be a security expert running these static analyzer and patchers, which are great, but sometimes could be a little bit hard to use. So going back to your question, I think we need to start seeing more processes and technologies that allow the people that are in charge of security at each of these protocols or community members to either prevent or amend issues pre and post deployment. So the role that we play at OpenZeppelin and what we think Defender 2.0 comes to address is providing all of those best practices that we've learned in the past 7 years by auditing lots of projects and also working on the OpenZeppelin contracts library and building those processes into technologies that any developer can use easily.
That's very interesting. And Emiliano, what do you think? Where we should get better? In what places? Is it like the audit phase? Is it like the deployment, the IR? What are the most important things in your opinion? And how do we actually get better? Education?
Yeah, I resonate a lot with what Demi just said. If a few years ago you can say we didn't have any proper tooling, people was not aware of the practices, X was limited. In 2023, we have several examples of how you can improve, and adoption is a big point here. I think that security industries has the responsibility, and it is really doing a great job. See OpenZeppelin, but all the industry showing what's the way, okay, lowering the entry barrier. I think that if you have a responsible developer, maybe they don't know about the security at first because maybe they don't have the experience. But as soon as they saw, some information about that, some examples, some templates, some, something, and understand that it's important, then we already have everything, from Defender 2.0 that is really giving you a very good entry for the security, to looking on your own about information. On information about security. So if I have to, let's say, point a specific area, I think we have plenty of auditing, plenty of tooling right now. Maybe we have to focus a little bit more about, IR, making maybe some war room games or some simulated scenarios, and let people see how to manage those kind of situations and fill them. That's a thing that definitely could help to, because if we saw about past examples, many X couldn't be prevented, because it would be a lie to say we give you the tool that cover 100% of the stuff. We give you a process, but at least you are prepared and you mitigate the max potential loss. And there, being prepared and react time wisely and know who to reach out and which role is yours is critical in this stuff. So if I can recommend to any developers out there that is listening to us, I want that they come back and say, okay, how we are ready to a security incident? Do we have everything? Do we have a process, some list of things, some list of contacts? We know where the people are at the moment. We have backup contacts. Just the inception of, okay, but what would happen? Okay, without any answers. Okay, but that's important. And starting from there, improve time by time, because it's a continuous process. You have to make mistakes, but it's better to make mistakes in a simulation environment rather than, when the real funds are at risk.
Yeah, I definitely agree that we are focused a lot on audits, but it seems like, projects, if they don't really feel it, they don't really think about the place where in the middle of the night there will be like the TVL will just drop, and it's a very scary moment. And I believe that really there will be more awareness regarding this, like education or preparation for this kind of doomsday. And I believe that also Defender 2.0 will help a lot, both in the tooling phase and also in the, I would say, awareness of it. Because if a DApp is using Defender, he will see the sections of like monitoring and IR. Obviously, we'll start exploring those modules and see like, oh yeah, I can set up monitors, so I can set up actions, and it will change the perspective that he looks on the whole development process and the security, in my opinion.
Just to share a last word on this, but then I want to hear the take by Juan, is you cannot delegate security outside to any tooling, to any audit company, to anyone. You are the ultimate owner of security of your protocol. You are responsible of your user somehow. Okay, we know this, smart contract is low, blah, 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 but you are the owner. Like in a DevOps model, you are the owner of what you build. Okay, set the expectation correctly if you want to be the owner or not, but you cannot delegate. So I've seen many developers that right now are thinking, yeah, you know what? We don't trust anymore so much auditing companies. We are starting to embody. And that's, for me, is a success for the industry, because it means that developers say, okay, it's on us. The industry can help us, but we cannot outsource that.
We cannot rely on the companies in the industry, but we need it needs to come within the team, within the developers, the education, the awareness, but you still need this support from like outsourced companies and tooling, but don't rely on them. Yeah, that's how I see it. Juan.
Yeah.
Yeah.
And I think that takes us to what we started discussing at the beginning, the development life cycle, and how important it is to take into consideration security from the first moment, which is when you plan what are you going to code, to the moment when you start creating pull requests, as like the first time you start creating the pull request on GitHub, to have the right tools, as Demi said, to start finding issues. That's also an educational resource. If you code something, you create a pull request with new functionality in your smart contract, and you have a tool that is telling you that a function might be reentrant or might be vulnerable to a reentrance attack, or or issues like that, you start reading more about, oh, okay, what is a reentrance attack? And you learn. So it's also like a good source for developers to understand what are the potential vulnerabilities that they might face during the development life cycle. It's also very important to notice that audits are still very important, and they're probably the ones that get at least 90% of the issues that someone can find in a code base, and making easier the process for auditors and for companies in a standard way to interact is also key for success. Defender, as a matter of fact, brings a new tool which allows both auditors and PMs from audit teams and protocol developers to interact so that developers can read the issues that auditors have been raising, and they can address them directly there, and then auditors can see the fixes, can go through the pull request that fix a certain issue, and then give feedback or start conversations there in the platform in order to come up with the best result.
Definitely, and it seems like it's really going to be a game changer, and I truly believe that it will be very useful to a lot of developers and security researchers as well. So whether if you're a developer creating a DApp or a Web3 security researcher, definitely go head over to OpenZeppelin Twitter page, go to the website and check out Defender 2.0. They just launched it today, the beta version, and just my honest opinion, it's pretty incredible. So definitely check it out, either if you're a developer or a security researcher. Any final thoughts, guys? Demi, do you want to add something? Any final thoughts about where we are going, about Defender? Yeah.
Yeah, no. First, I'm going to say this has been a really interesting conversation. Those were really good questions, Johnny. So thank you for that. And thank you for the kind words on Defender. We're pretty excited based on it's built based on our learnings working with our community of developers and protocols and DAOs. So also a big thank you to our community for that. I wanted to ask you, you've been asking all our questions. I wanted to ask you, Johnny, so where do you think the blockchain security space is going or should be going?
So I believe that the more time passes, there are more people that becoming aware of blockchain and blockchain security. You know, everyone says that we are in bear market and stuff, but there are still a lot of developers and creators that are coming up with awesome ideas, creating dApps, creating protocols, DeFi protocols. And at the same time, you see a lot of people that are joining and becoming security researchers. One of my goals is to improve the education in the space. That's why I'm creating a lot of content. That's why I created the course and working now on the certification. And I believe that the more time passes, we will keep up with Web 2 traditional security, and you will see more people both like we have different professions. We have like penetration testers and IR and SOC and malware analysts. So we'll have different professionalities within Web3 security. So you will have someone is more focused on auditing. Maybe someone is auditing Cairo smart contract, and someone is auditing, other smart contracts. And you will have someone at whole specialty is to look at malicious bytecodes that were deployed to exploit smart contracts. Someone will be in the MEV of like how to front run malicious attacker to white hat hack protocols and save funds. So I believe that we are in a good direction, and hopefully we'll be able to decrease this total amount of numbers with tooling, with education, both developers education or bringing more talents to the space from Web3 or Web2, because there are a lot of brilliant minds in Web2 security that don't even know what smart contracts are and what is blockchain security, and they don't even understand that, okay, once you have a hack in a network, there could be a ransomware that encrypts hard disk, but once you have a hack in a decentralized protocol, just all the value is being stolen and you cannot revert the state. So it's gone forever. So I believe that more and more people will be aware of it, and we will see more smart people and becoming developers, becoming security researchers. And that's how I look at it. Yeah. Hope it makes sense. Yeah. So guys, if you have any questions, feel free to ask them in the space itself. And meanwhile, any final thoughts, closing, something that you want to say, Emiliano, Juan?
Wanted to thank you for inviting me and share my thought about the security space. I'm pretty happy to see a player like OpenZeppelin doing investments like Defender 2.0. And I definitely think that this would trigger, a new wave of tooling and people approaching security more easily, and that will generate more adoption for sure. And I think that security, I mean, if we believe in the long run that this industry should have a future, I think that we will solve these security challenges. There is no reason why we should not, because in any other industry, from cars to Web2, they faced similar issues. There are many analogies that you can make, and they managed. We have a powerful tooling, we have a powerful technology. It's just up to us to find a way. So my final thought would be, I know that many times we talk about bull market, bear market, or whatever, that someone is here for the tech or someone is here just for the money. I think that if we stay here and we are happy to what we are building here and we want to stay here in the long run, we will manage all these challenges, and this industry will have definitely a future.
Thank you for the positiveness, Eliano. This is important. And yeah, definitely. Juan.
Basically, we have to understand how important security is. All these protocols, there are so many teams in the Ethereum ecosystem and other blockchain ecosystems building super cool stuff that are going to be the economy of the future. And all this has to remain secure somehow. And we have to understand that we cannot rely on normal manual processes such as audits. We have to understand that as developers can make mistakes when they write code, auditors can also make mistakes, because an audit is, in the end, a project that has a start, has an end, and it's performed by humans, and humans can make mistakes. And the more things we can standardize in terms of security, the better for the ecosystem. The more tools we can have out there to use to ease developers, the developer life cycle, the developer experience, and also the auditor experience, the better for the ecosystem. This is the way or in my opinion, we're gonna accomplish the goal, which is protect the open economy and mitigate as much as we can vulnerabilities and hacks in the future.
I highly agree with that. And it seems like OpenZeppelin is definitely dedicated to this task, protecting the open economy through tooling, through audits, through everything, through the libraries, the library of the best practices of the EAPs is amazing contribution to the open economy. And this is everyone, I think, is grateful here for that. All right. So Thank you so much, guys, for your time. It was a pleasure talking with you. I hope that all the people who joined enjoyed the conversation. And again, if you want to try out, it's for free, the OpenZeppelin beta version, the Defender 2.0. So head over to OpenZeppelin Twitter account and go to the website and to the Defender. And thank you so much.
Thank you, Johnny. Great conversation. Also, thank you to Emiliano and Jota, two thought leaders in the blockchain security space. Always a pleasure to talk to you guys.
Thank you all. Great talking with you guys.
Thanks. It was great.